We continue with rational expressions, and now we want to add and subtract rational expressions. I'm going to start simple with numbers. Suppose we want to add 1 over 2 and 1 over 24. The denominators are not identical, so we want to find something called the least common denominator. So let's take the first denominator, which is 2. We could write that as 1 times 2. The second denominator is 24. We could write that as 1 times 2 times 2 times 2 times 3. Now we have to isolate the common factors. 1 and 1, we have 1. 2 and 2, we have 2. And the others don't have anything in common, so we simply write them down. So that would give us 12 as the least common denominator. We want to extend this to rational expressions where we have expressions such as this one, but this one's kind of easy because we have identical denominators, so we simply put that denominator that is in common already and combine the numerators, which is 4p minus 3 plus 3p plus 8. So 4p plus 3p is 7p, and 8 minus 3 is minus 5, so the answer is 7p minus 5 divided by 2p plus 7. This problem is on subtraction, but we still have a common denominator, which would simply imply we put the common denominator, y minus 2, and simply combine the numerators, which is 8y minus 16. You should always ask the question, if you can simplify. I see common factor of 8 in the numerator, so if I pull that out, I have 8 times y minus 2 divided by y minus 2. The y minus 2's would go away, resulting in 8 divided by 1, so the answer is 8. So here is a lengthier expression in the denominator, but once again, that denominator and that denominator are in common, so I simply write that denominator down and I combine the numerators. 3y, there is a subtraction sign in the middle, minus 6. I see a 3 in common, so I pull that 3 out. I get 3 times y minus 2. The denominator has y squared plus 3y minus 10. We'd like to know if I could write it in terms of y minus 2 so I can cancel the common factor. If I factor the denominator, I could write it as y plus 5 times y minus 2. So I have a common factor between the numerator and denominator, which I will cancel, leaving me with 3 over y plus 5. If we do not have a common denominator, as I mentioned earlier, we want to find something called the LCD, which is the least common denominator. So here, we don't have identical denominators, so we start with 6y, which we can write it as 1 times 2 times 3 times y. We could write 4y plus 12 as 4 times y plus 3, because 4 is in common between 4 and 12. And I could rewrite 4 as 2 times 2 and times y plus 3. Let's see what we have in common. 1, obviously, it's in common. A 2 is in common. So the LCD is 1 times 2. The other terms don't have anything in common, so we simply write them down. 3 times 2 times y plus 3. So the answer is 12y times y plus 3. So here we have a lengthier expression in the denominator. So our goal is to factor first, if at all possible, x squared plus 4x plus 3. We could write it as x plus 1 times x plus 3. The denominator, x squared plus 10x plus 21, we could write it as x plus 7 times x plus 3. Between those two denominators, we have x plus 3 in common. So the LCD is x plus 3, and there is nothing common between x plus 1 and x plus 7, so we simply write it down. So the LCD is x plus 3 times x plus 1 times x plus 7. Here is another example. The denominators are not identical. So we have 5x squared minus 5, which I could write it as 5 times x squared minus 1, because we have a 5 in common. If you recall, a squared minus b squared can be written as a plus b times a minus b. What we have here is x squared minus 1 squared. That would be x squared minus 1. So a is x and b is 1. So if we plug that in our identity, we would have x plus 1 times x minus 1. So I can rewrite 5 times x plus 1 times x minus 1. The other denominator, x squared minus 2x plus 1, can be written as x minus 1 times x minus 1. Let's see what we have in common. X minus 1 is in common. So we write x minus 1. The other terms don't have anything in common, so we simply write it down. So the LCD here is 5 times x minus 1 times x plus 1 times x minus 1, which is simply 5 times x minus 1 times x squared minus 1. Again, I'm using the identity which we had earlier. X plus 1 times x minus 1 is x squared minus 1, so I simply rewrote x plus 1 times x minus 1 as x squared minus 1. So this is a tricky one because we have x minus 3, which is simply x minus 3, but 3 minus x is very much alike compared to x minus 3, except for one difference, that there is a switch in order. 3 comes in the front and negative x later, so I could write 3 minus x as negative 1 times x minus 3. So the common factor here is x minus 3. Since there is no negative 1 In the first denominator, we simply throw that in there, so the LCD is negative times x minus 3, which is 3 minus x. So our objective now is to add or subtract rational expressions with unlike denominators. In other words, the denominators are not identical. So the first step here is to find the LCD. Second step, rewrite denominators to appear as the LCD. Combine the numerators and put it over the LCD, which is common to both the denominators. Identify common factors between the numerator and denominator. If possible, sometimes it is not possible, cancel common factors and simplify. So here we have two distinct denominators. So let's write 7a as 1 times 7 times a, 6a as 1 times 6 times a. So the LCD would be the common factor 1, the common factor a. 7 and 6 have nothing in common, so we simply write it down and we end up getting 42a. Our objective now is to convert both denominators to 42a. So I am going to multiply and divide the first fraction by 6. I'm going to multiply and divide the second fraction by 7. In doing so, I would have 15 times 6, which is 90 over 42a, and 8 times 7 is 56 over 42a. I'd end up getting 146 over 42a. So could we simplify this further? So clearly we have a 2 in common. I could write it as 2 times 73 divided by 2 times 21 times a. So the 2's would go away. The final answer is 73 over 21a. So if you notice here, 2x minus 6 and 6 minus 2x are in opposing orders. So I could write 2x minus 6 as is, and 6 minus 2x is simply negative 1. If I pull negative 1 out of 6, I have negative 6. Pull negative 1 out of negative 2x, I have positive 2x. So I have negative 1 times 2x minus 6. So the first denominator is 2x minus 6. The second one has 2x minus 6. The LCD is 2x minus 6. And negative 1 is not in common, so I simply put that down. So this sort of tells you what you need to multiply and divide by. The fact is that it's not in common. So we want to multiply and divide 2x minus 6 by negative 1. I'm sorry, the first rational expression, multiply and divide by negative 1. We'll keep the second as is. 5 times negative 1 is negative 5. If I distribute the negative, I end up getting negative 2x plus 6 minus 3 divided by 6 minus 2x. But you have to realize that negative 2x plus 6 is simply 6 minus 2x minus 3 over 6 minus 2x. I have a common denominator, so I'm going to put that common denominator and combine the numerators. So we have negative 8 over 6 minus 2x. If we can't simplify it further, we should make an attempt. I could write negative 8 as negative 4 times 2. There is a 2 in common in the denominator, so if I pull that out, 2 comes out, 6 becomes 3, and negative 2x would simply become x. I can cancel the 2's. So the answer is negative 4 divided by 3 minus x. This is a lengthy one, so the denominators are not identical. So we could rewrite x squared minus x minus 6 as x minus 3 times x plus 2. In terms of its factors, I could write x squared plus 5x plus 6 as x plus 3 times x plus 2. So the LCD is the common term, which is x plus 2, x plus 2. The others have nothing in common, so we simply write them down. So let's start by rewriting the denominator in terms of its factors. X minus 3 times x plus 2 in the first denominator, plus x divided by x plus 3 times x plus 2. Our objective is to convert the two denominators to look like the LCD. The first denominator here has x minus 3 and x plus 2. It is missing x plus 3. So I'm going to multiply and divide by x plus 3. So I have x minus 3 times x plus 2 times x plus 3. Likewise, the second denominator here is missing x minus 3. So I am going to multiply and divide by x minus 3. If you observe, now both denominators look identical, and it corresponds to the LCD. So we combine the denominators and write it as a single denominator and combine the numerators. So 4 times x plus 3 plus x times x minus 3, which would give us 4x plus 12 plus x squared minus 3x divided by x minus 3 times x plus 2 times x plus 3. If we simplify, 4x minus 3x is x, and we have 12, divided by x minus 3 times x plus 2 times x plus 3. In this problem, we have the first term, which is x minus 1. It is a factor by itself. The last term, or the last denominator, is x plus 1, a factor by itself. But the middle one is x squared minus 1. But if you recall the identity, is x plus 1 times x minus 1. So, the first denominator is as is. The second denominator is x plus 1 times x minus 1. And the second, or the third one, is x plus 1. So, we have x plus 1 in common among all three. And we have x minus 1 in common. So we wrote the common factors. So if we rewrite the original expression, we have 7 over x minus 1 plus 10x. I'm going to rewrite x squared minus 1 as x plus 1 times x minus 1. And the last expression as negative 5 over x plus 1. Our objective now is to convert that denominator and that denominator to look like the LCD. So the first denominator has x minus 1, but it is missing x plus 1 because our LCD is x plus 1 times x minus 1. So we multiply and divide by x plus 1. We leave the second term as is in the denominator because it looks like the LCD. And the last term has a denominator of x plus 1. It is missing x minus 1. So I multiply and divide by x minus 1. If you observe now, the denominators are identical and they resemble the LCD. So we put that common denominator and we combine the numerators. 7 times x plus 1 plus 10x minus 5 times x minus 1. We distribute and simplify. 7x plus 7 plus 10x, negative 5x, negative 5, negative 1 is positive 5, divide by x plus 1 times x minus 1. 7 plus 5 is 12. 7x plus 10x is 17x. 17x minus 5x is 12x, divided by x plus 1 times x minus 1. We have a 12 in common, so if I pull that out, I simply have 1 plus x divided by x plus 1 and x minus 1. And those two terms are the same, so we would cancel that, and our final answer would be 12 over x minus 1. This problem might seem complicated, but in fact it is not. We have x minus 1 times x plus 1, x plus 1 times x minus 1, x plus 1 times x minus 1. 2 times 3 is the same as 3 times 2. So x minus 1 times x plus 1 is the same as x plus 1 times x minus 1. So we have 7x plus 7 divided by x plus 1 times x minus 1 plus 10x divided by x plus 1 times x minus 1 minus 5x minus 5 divided by x plus 1 times x minus 1. We have a 7 in common in the first numerator, so there might be a possibility to simplify. So I pull that 7 out, leaving me with x plus 1 in the numerator. And you may say, well, let me just do that and everything would be peachy, but you have to be careful. Reason being, once we cancel this out, we would end up having 7x minus 1. So let me rewrite. The second term would remain as is. The third term has a negative 5 in common, or 5 in common, so I could write it as 5 times x minus 1 divided by x plus 1 times x minus 1. You may merrily cancel those two and those two terms, and you will write it as 7 over x minus 1 plus 10x over x plus 1 and x minus 1 minus 5 over x plus 1. What did you do? So here, we simply made it more difficult. Why? We started with a nice little common denominator there. We started cancelling out and we ended up getting that. The denominators are no longer identical. So we have to find the LCD, and which would turn out to be that indeed. So when we divide, if we have a common denominator, just combine the numerators and let us go from there. Because as we saw in this problem, sometimes cancelling and simplifying, then trying to combine the rational expressions could lead us in trouble, because we moved from having a nice common denominator to here where the denominators are not identical. So what we're going to do is go to the step prior to having common denominators, or prior to having unlike denominators. So since we have common denominator, we simply put that down here and combine the numerators. So we have 7x plus 7 plus 10x minus 5x minus 5. That would give us 7x plus 7 plus 10x. Distribute the negative. We have negative 5x plus 5 divided by x plus 1 times x minus 1. 10x plus 7x is 17x. 17x minus 5x is 12x. 7 plus 5 is 12 divided by x plus 1 times x minus 1. We have a 12 in common in the numerator. So if we pull 12 out, we have x plus 1. And in the denominator, we have x plus 1 times x minus 1. We have x plus 1 in common. We cancel that. We end up getting 12 divided by x minus 1. And that is the simplified answer.